Okay, let me discuss the next problem. So this is 7.41. Interesting problem this time. Something related to competition between SN2 and E2 reaction. So basically E2 and SN2 always in competition. So for the same reaction you can have E2, and for the same you can also have SN2. So there are two paths. You can either have SN2 reaction or you can have E2 reaction. So this question is something that related to this one. So this is a treatment of 2-bromopropane. So you have a 2-bromopropane. So let me write. So this is CH3 CHBr CH3. So this is 2-bromopropane. So this is a treatment of 2-bromopropane with a solution of ethoxide ion. So if you treat with OET minus, now this can act as a base as well as nucleophile. OET minus can act as a base as well as nucleophile. Now on secondary substrate, so what is the carbon? Alkyl halide is basically 2-degree alkyl halide here you have. On 2-degree alkyl halide, elimination and substitution both happens. So either if I have elimination, it can take H plus Br goes double bond I will have. If it acts as a nucleophile, this goes and this will have. So we will have substitution and elimination both product. Let us discuss the question and then we will discuss what the says. It says gives a product of mixture of containing 75% propene. So one product you are getting is propene. So let us say, let me write here. So you are getting one product CH3 CH double bond CH2. So this is one propene. So let us say 1, 2, 3. So this is one propene. So you are getting one product is one propene, that is a E2 elimination. So this product is coming from E2 because elimination is happening. Are you getting? So you have to release H and Br. So both is happening in the same case. So OT minus is a good base in this case. So it is acting as a. Now the second product says, and you also get 2-ethoxypropane. So at the position number 2 you add ethoxy group CH3CH CH3, and if you add here OET group, so this is a substitution product. So this attacks here Br goes. So this is your SN2 product. And now question says 25% substitution product you have, that is this product is 25% and the upper product is 75%. So mainly you have elimination. So in this case this product is 75%. So what you have? Mainly you have elimination and less you have substitution. So majorly in this case you are getting elimination. Now the same reaction with hexadeutyro 2-bromopropane. You getting? So it says hexadeutyro 2-bromopropane. Now this reaction is done. So what we are doing is, and this hydrogen are basically replaced with deuterium. So let us say, question says, now we do this question with this one CH3, only hexa, so I have to replace only 6 deuterium. I don't have to replace this one. Are you getting? So hexadeutyro CD3 and Br. Okay, I think you have not seen. Okay, let us copy. So I am saying hexadeutyro 2-propane. So this is hexadeutyro 2-propane. Bromopropane, you can say hexadeutyro 2-bromopropane. So this is your hexadeutyro 2-bromopropane. If you have not written on the top, let us copy this fast. Okay, so now this says if I do the same reaction with OET minus, in this case it says it gives a 31% of alkene. So the first is with E2 elimination I am getting a product, and this product is CD3. So I have CD3 here and CH double bond CD2. This is now only 31%. So elimination is 31%. Now see, this elimination product has reduced. Initially this was 75%, now this is 31%. Now if I do substitution, it has to increase, because if one reduces then other has to increase. Are you getting? Because the total I have to have 100% in this case. So the other product is CD3 CH CD3, and here you have OET, this product, and this product question says is 69%. So substitution product is 69%. Now you have to tell me what is the reason, why this is happening, why all this is happening. So if you see, if I replace carbon hydrogen with deuterium, the substitution product increases, but elimination product decreases. So elimination product is decreasing and substitution product is increasing. Are you getting why this is happening? Now this must have to do something with carbon deuterium bond, because I am replacing the carbon deuterium bond. So I have to see the answer in terms of carbon deuterium bond, and I will give you a hint. You look the mechanism and then you will get the answer. So you have to look the mechanism. In E2 mechanism, in RDS, that is in the rate determining a step, does CD bond breaks? If it is breaks, then it will basically change the rate of reaction. But what does it breaks in the SN2 reaction? So let us take half minute time. So you have to write down the transition state, you will get the answer. If you write down the transition state, you will get the answer. So just write down the transition state for E2 and SN2, you will get the answer. Okay, let me show you for you. So you see, if you have CH3 carbon and here you have bromine, so I am writing for this is this transition state, I am writing for E2. So let us say I have hydrogen and here I have carbon. Let us say this bond either it can be hydrogen or it can be deuterium. Let us say if I take hydrogen, take the hydrogen case, H. So what is happening in our rate determining step? OUT minus, this takes this one and this bond goes here. So you see this bond goes here and the same time this bond goes here. So you see the transition state CH3 CH, you will have here Br. I have to go fast. I have to Br and this bond, I have a double bond character and CH. H, this bond is broken and this is attached with OET. Are you getting? You can put the charges also. Are you getting or not? So Br will have slightly minus charge, this will also have slightly minus charge. Now you see in this transition state this bond has broken. So carbon hydrogen bond has broken. Now I know if I take deuterium, then in that case we will have carbon deuterium bond that has to broken. Now I know CD bond is stronger than carbon hydrogen bond. So if I change carbon hydrogen to carbon deuterium, rate will decrease. Are you getting or not? CD bond is stronger than CH bond, so rate will decrease in this case. Rate will decrease. Are you getting? And once the rate decreases, in that case product percentage will also decrease. And that's why initially it was 75% and now it is only 39%, 31%. But if you see SN2 mechanism, what is the transition state? You have CH3 here, you have CH3 here. Now here you have hydrogen, and what happens? Bromine goes and some nucleophile attacks. So this is your transition state for basically SN2. So in this case bromine, carbon bromine bond is important. Carbon hydrogen bond does not break. So carbon hydrogen, if I replace this carbon hydrogen to carbon deuterium, it does not change. So carbon deuterium bond does not affect the transition state of SN2. So carbon deuterium or carbon hydrogen does not affect the rate, does not affect RDS. This means the substitution percentage has to increase because total I have to have 100%. So basically SN2 reaction rate does not change. If I change carbon hydrogen to carbon deuterium, rate will remain same because carbon deuterium bond does not come into the RDS step. But what happens? The rate of elimination goes decreasing. If elimination rate decreases, then substitution rates by itself, by default, increases, because I have to have total is 100%. So if somebody decreases, then other even does not increases, it increases automatically, because it's total I have to have 100%. And that's why substitution product increases. Initially the substitution product, if you have written in your copy, it was, you see here, initially it was 25%, now this is 69%. So this is increased. Even though the rate has not increased, for SN2 rate has not increased. The main thing is the E2 has decreased, and that's why SN2 has increased. And that's happened. Sometimes you see something that goes down, other itself goes up. So let us copy this one first, and then we'll go for the next problem. So this is a quite interesting problem. So you see this problem says something about competition between SN2 and E2 reaction. So you see the same nucleophile, same OET minus can act as a E2 elimination as a base, or it can act as a nucleophile. If you have a secondary substrate like secondary alkyl halide, on secondary alkyl halide both happens, elimination as well as substitution. Now it only depends upon the condition of temperature and experimental condition. You changing the experimental condition, you will have more substitution or more elimination product. So you see, now in this case, if I change the carbon hydrogen to carbon deuterium bond, the product of SN2 increases, because of carbon deuterium bond does not comes into the picture of SN2 mechanism. It comes into the E2 step, E2 transition step it comes, because here I have carbon hydrogen, I can change this to carbon deuterium, so it comes into the picture. Are you getting or not? So let us copy this one, and then we'll go for the next problem fast. I think all of you have copied this one. Those who have not copied, please do fast. Okay, let us discuss the next problem.